So you know that gravity is the attraction between two objects. So gravitational force is the attractive force between two objects. It's the force that attracts them together. And it is affected by the mass of the objects and the distance between them. So the greater the mass of the objects, the more the gravitational attraction. The greater the distance between them, the less the gravitational attraction. When we talk about gravity, we can represent it two ways. And we're going to look at the force of gravity. So Newton was a physicist that developed this law of gravity. If we look at Newton's law of gravity and how it's represented mathematically in a formula, we look at the force, which is F, the lowercase g. So really, when we talk about gravity, there's two ways we can talk about it. We can talk about the force that attracts two objects together and the gravitational constant. So to figure out the actual force of gravity between two objects, we have to use what's called a gravitational constant. So the gravitational constant is indicated by the letter big G for gravity. So big G is a constant. Big G is a constant. That means it doesn't change. In the entire universe, big G stays the same. And the number is 6.674 times 10 to the negative 11 newtons per kilograms squared, meters squared. So this is the constant of gravity, the gravitational constant. This is it. If I were to write this number out, it would be, there'd be a lot of zeros. So let's see this. 0. So this is actually what the number looks like if we write it out. Lots of zeros, actually 10 zeros. So 0.000000000006674 newtons per kilogram squared per meter squared. So this is a very small number, but it is a gravitational constant we use to determine the force of gravity between two objects. So that is big G. But if we want to figure out the gravitational force between the objects, we have to use this. But not just that, we also have to look at the masses of the objects and the distance between them. Because remember, we said the two things that affect the force of gravity are the masses of the objects. So the more massive the objects, the more gravitational force. The more distance between the objects, the less the gravitational force. So we're going to multiply mass of the first object, which we're going to indicate M1, times mass of the second object, which we're going to indicate by M2. So these are the masses in kilograms. We're going to divide that by the distance between them squared. So this is the formula for gravity, force of gravity. It's Fg equals the gravitational constant, which is 6.674 times 10 to the negative 11 newtons per kilogram squared per meter squared, times the mass of the first object times the mass of the second object, divided by the distance squared. So let's look at an example of how to use this. If we have two objects, this is M1, this is M2. And we know the masses of the two objects. And we know the distance between the objects, which is d. We square it, we can actually figure out the gravitational force between them. In other words, what is the force of attraction? Okay? So let's look at an example to determine, so we're going to look at an example here. We want to know the gravitational force between Jupiter and Saturn. So, here we have Jupiter, let's say, and here we have Saturn. So let's label them. Okay, we're going to make Jupiter M1. It doesn't matter, I can make Saturn M1, doesn't make a difference because we're multiplying them together. Okay, so I'm going to make Jupiter M1, Saturn M2. Now, so the mass of Jupiter is 6.4 times 10 to the 24 kilograms. This is mass of Jupiter, so we're going to make that M1. There it is. The mass of Saturn is 5.7 times 10 to the 26 kilograms. That's M2. So we have M1 and we have M2. Now, what's the distance between them? Remember, because to determine the force of gravity, we need to know the masses and the distance. Distance between them is 6.52 times 10 to the 11 meters. We now know this is distance, that's d. So we know all of these numbers now. So what we're going to do is put these numbers into the formula. Plug in the numbers and solve for F, because that's what we want to know. Now I know these numbers, so I plug them into the formula. So Fg is equal to 6.674 times 10 to the negative 11 times 6.4 times 10 to the 24th times 5.7 times 10 to the 26th divided by 6.52 times 10 to the 11th squared. So, in math, parentheses first. So we're going to go with parentheses, and now this one, it's like a double parentheses. So we're going to do this part first. So we take this number and square it. So that means we take this number multiplied times this number. So I'm going to write this out and show you how it's easy to multiply with scientific notation. First thing you do when we're multiplying numbers that are written in scientific notation is we're just going to multiply these first numbers. So these two, 6.52 times 6.52. Rewrite this denominator. So the denominator, 42.5. Now this is what's easy with scientific notation. When we're multiplying two numbers that are written in scientific notation, you just first multiply the first numbers times 10. The exponent, in multiplying, you add exponents. So you're adding 11 and 11, 22. So this is going to be the number in the denominator now. So I'm going to go back and just rewrite that number right here. We have this number times this number. So we're going to multiply this times this. So 6.4 times 5.7 is 36.48. So right now I am, let's say 36.5. Okay, so now we're going to just rewrite this numerator. Okay, so we'll take this number times this number times 10. Remember, we're multiplying, so we're adding exponents. 24 plus 26 is 50. So this is in the numerator now. So I'm going to put this right here to simplify. We're down to this. Next thing, we still have parentheses, so we've got to do what's in the parentheses here first, since we've got division here, and then we're going to multiply them together. So we're going to take, now we're dividing two numbers written in scientific notation. It's easy to do. You just take this number divided by that.